Hi, my name is Anna, and I'm an instructional designer at Sumo Logic. In this video, I'll demonstrate how to use Root Cause Explorer to observe, analyze, and troubleshoot an incident faster with the help of a scenario. Here's a scenario where I'll use Root Cause Explorer to troubleshoot and isolate the root cause. This sample app helps travelers book their flights online and provides the associated services including hotel booking, sightseeing, and arranging visits to well-known places at the destination. The app runs on AWS and uses certain AWS services, including ELB, Application Load Balancer, Host EC2, and DynamoDB. The app faces unusual latency while loading. The end users have experienced outages in the application with 500-level HTTP errors in the US East 1 area in the last 24 hours. Let's see how a DevOps specialist can use Root Cause Explorer to analyze and identify the root cause of the outages faster. For this demo, I'll click plus new and select Explore, where I can filter out the events of interest for AWS before opening them in Root Cause Explorer. In the top left corner of the screen that displays, I'll click under Explore By and select AWS Observability. Next, in the left pane, under the prod account, I'll click the US East 1 region and select the AWS/application ELB. Scroll down to see the 5xx by load balancer dashboard and look for the most recent outage in the EC2 ALB with 500-level HTTP errors plotted. I'll click the most recent spike in the 5xx by load balancer dashboard. The Entity Inspector panel opens in the right pane. To open the event of interest, I'll click the Entities tab next to the Summary tab. And then open the entities in the Root Cause Explorer screen by clicking Open in Root Cause Explorer. The various filter options can be used to filter out the relevant events in the AWS and Host panel, such as region, entity type, and entity, to name a few. To see the events of interest stats, I'll hover my mouse over the plotted error. Hovering the mouse slightly above reveals that the EC2 CPU log bottleneck event is plotted slightly earlier. And, moving further up, it shows that the DynamoDB throttle event is plotted earlier than the CPU load bottleneck. When I consider these events and their timeline, I realize that DynamoDB got throttled first, and the rest of the events occurred as cascading effects of the database throttling. Knowing that the DynamoDB throttling may have caused the outage, I want to find out how and why. So, I'll click the DynamoDB event plot and check the details displayed in the Summary tab in the Entity Inspector panel. A spike in the metrics chart is seen plotted below the Summary tab. Then, I'll click the Entities tab where the relevant entities and environment parameters are listed. I'll click Open in the Entities section, and then select Entity Dashboard to open the relevant entity dashboard. Then, I'll click the relevant DynamoDB Events dashboard by clicking the AWS DynamoDB Events option from the dropdown. Remember, the data in the dashboard is fetched using the relevant metrics. The dashboard displays a number of panels, including total errors, top 5 events, and events over time. To drill down into the logs further, I'll scroll down to see all table events and click Open in Search to see the relevant logs. In the aggregate events, I see that a few people have updated the table. I'll click Messages to analyze the logs further in depth. All the log entries are displayed. If required, the filter in the left pane can be applied to focus on the relevant fields and search throughout the event. For this video, I'll filter the log entries to display the Update Table events. Going through the Update Table log events reveals that there is a change in the provisioned throughput of the DynamoDB table. Someone has changed the read-write parameter to decrease the capacity. With that, it becomes evident that a developer reconfigured DynamoDB. They used lower provisioned IOPS, input-output operations per second, which caused throttling and the subsequent outage. Cost optimization could have motivated the developer to make the change. Remember, for DynamoDB, AWS charges based on a provisioned read-write capacity units. So here, it can be concluded that the real root cause for DynamoDB throttling is a change in the provisioned IOPS setting of a table. Lowering this setting while lowering AWS costs can also lead to throttling. Such a configuration change might be evident in AWS CloudTrail logs associated with DynamoDB. And reconfiguring the IOPS value to the allowed range will resolve the issue. I hope this video helps you understand how to use Root Cause Explorer to diagnose, analyze, and troubleshoot an incident faster. Thank you for watching.